Write 6.04 times 10 to the 5 as an ordinary number. So it would be 6.04 and then just put loads of zeros on it and then literally go 1, 2, 3, 4, 5. So that would be 604,000. 1, 2, 3, 4, 5. Yeah. And it's not about the zeros after the 6, it's about the numbers after the 6. That's what my students often make mistakes with. Right, write this as in standard form. So we go 1, 2, 3, 4, 5. So it's 7 times 10 to the power negative 5 because you're going to the right. And that can go in there. Give your answer in standard form. Literally, this is... you can put this into your calculator as you have a calculator. So it's 7.6 times 10 to the power 10 over 4 times 10 to the power 5 minus 2 times 10 to the power 4 equals, and that's 200,000 according to this. So at the bottom we have, that would be 40,000 minus 2,000, which is 38,000 or 3.8. And then that is, so that's 3.8 times 10 to the power 4. Yeah, that works because that's half of 7.6 and that's 10 to the power 6. So that means that's 2 to the power 2 times 10 to the power 5. 1, 2, 3, 4, 5. Okay, I'll take that. I think I'm just one out in terms of looking at it. Right, the diagram shows the hexagon. Well, we've got to calculate the area. So I'm not going to think about anything else first. I'm just going to assume the bottom bit here is a, what's the thing called? It's a rectangle, so it's 23 times 4.7, which equals 108.1. So just remember to add that on at the end, because I've got this funny feeling I'm not going to. Right, how do we find the area? Is that trapezium? 23. Ah, the only thing is, yeah, it is a trapezium, the top, but we don't know the vertical height. So if we can find out what this is here, and we can, then we can do just a trapezium. We can do the area of a trapezium and it will be fine. So that's 5, that's 30. And so that would mean that we know this is opposite, this is hypotenuse. So we know that the sine of 30 equals opposite over 5. So 5 sine 30 will find us what this is here. Equals, oh, that's 2.5, I think. So sine 30 times 5 equals 2.5. So 2.5 or 5 over 2. So to find the rest, we just do 23 plus 11 over 2 times 2.5. And that will equal this bit of the whole thing. And that is 23 plus 11 equals, divided by 2, 17, times 2.5 equals 85 over 2, which is 42.5. So if we add 42.5 to that, we get plus 108.1, 150.6. There we go. And now this is a cumulative frequency table. It gives information about the time in hours that each 60 workers spent working from home in 1 week. Yeah, this is well after COVID, obviously. So let's draw it in. So 0 to 5 equals 6. So that's there. 10, 17. This is when it's quite hard doing this because you just, 27 is 15. Make sure you get the points right, otherwise you lose points. 20 is 42. I say that as somebody who doesn't always look where I'm putting things. And 25 is 53, so that's there. And 30 is 60. So there we go. Now you do a nice smooth curve. I'm sure your teachers have taught you this. Here we go. That's your smooth curve. None of these jagged edges. Use your graph to estimate the interquartile range of the times. So, what is a quarter of 50? I just really want to write in a different thing. I don't even read. Quarter of 50 is 15. And 3/4 of 15 is 45. That's 3 times the quarter. So if we go down here and we go there, I think that's 8. It could be 9. And then this one is further along than that. So drop that down, that comes to 22. So our interquartile range is 22 minus 8 hours, which is 14. Now, 25 workers spent more than W hours working from home. Use your graph to estimate the value of W. So, whoopsie-daisy, we know that 25 people did it. How many people? Oh, we've got 60. So that would be 60, 50, that. So this point here, these people spent this much time working from home, and actually that drops down to 17.5. So that means 17.5 is the point where they have been working from home. One of the 60 workers is chosen at random. This worker spent H hours working from home. Find the probability that H is between 5 and 10. Okay. So this chap, person, woman, they, even, were between there and there. So that's 6. That is, I don't know what that is, 18? So it's 12 out of 60, or 1/5. And that is where I will leave you. I've actually got to go and do a tour now.